Okay, as I said, I'm going to talk about multidimensional scaling, but we should start, I think, well, we should start in Germany because we're in Germany. So here's from actually Slepin and Broch, a collection of plausible positions on a left-right scale for German parties, gotten by scaling their platform texts, basically. So what I haven't, these are the parties and their dates, and what I haven't shown here are the 9,000 words, which in some sense, whose positions tell you why these parties are where they are. I've just sort of ordered them from left to right. There's nothing particularly meaningful there. Okay, we're starting here because this is one-dimensional text scaling, and I'm showing you the cases, and we're generating the items. So yeah, let's start there, and let's consider 4 questions. One of which I think is, relatively speaking, closed. Maybe I'm optimistic about that, which is, what do you have to assume about how real political positioning happens such that you can magically use a text scaling device to get those positions? So what's the positioning logic? And we'll talk about that just a little bit because it's going to be important as we go to higher dimensions. But what the focus of today is mostly going to be on is, if we didn't think there was a left-right scale, if we thought there was a space, as it were, rather than a line, then how would we place these documents, these parties, these platforms on multiple dimensions? Most importantly, how would we understand what we did when we did it? That is to say, we can generate large numbers of multidimensional scaling devices, and they're all kind of great, and they don't necessarily all agree, and so we have to decide how we interpret them. And a very related question to that for interpretation is, if I have several scales, how do I tell what on earth that scale is? Now, these are going to be very tightly interrelated. In fact, the answers to all these 4 questions are going to be tightly interrelated. So I'm going to start with relatively good news, and then we're going to then everything that's going to go wrong from there, essentially. So let's get going. So let's talk first about the logic of positioning in one dimension. So many of you have seen this idea before. If you've read an eternal preprint by me, then you will hopefully have been persuaded that when you are fitting, let's say, a wordfish model or one of these single-dimensional text scaling devices, we'll take wordfish as an example, then what you're really doing is making the following assumptions about politics. You're assuming that there is a line out there. It's an ideological space. Parties have positions on it. There they are, being pointed at from the bottom. And the things that they could, in this case, emphasize, let's think about this as a collection of CMP policy topics. So parties could talk more about freedom and human rights. And we think about that as having a position in the same space as the parties. And in particular, what we're going to show with all of these models is that parties say things in proportion to how far those things are away from them in this space. So the distance between the position of the FDP and the position of freedom and human rights, wherever those two are, is going to tell us how often that party should say that thing. And the relationship is generally going to be both unimodal and in particular quadratic. That is to say, as you get further away from having the policy position of the FDP, you get less and less likely in both directions to talk about freedom and human rights. We can tell this is true, very briefly, by writing down one of those quadratic models. That's the top line, which tells you how many times should I see the FDP talking about freedom and human rights. Consider the log of that rate. Then the thing on the top is some kind of quadratic relationship where the distance is going to be the position minus the position of the party minus the position of the thing it's trying to talk about. And that bit underneath is going to be how wide the quadratic is. That is to say, how far do you have to get away from being the FDP before you stop talking about that thing? So, and clearly, as you get further away from them, then you say it less, but the question is how fast in the space, as it were. That, if we look at the reduced form of that model, then we find something that looks like the equation on the bottom, which is a fixed effect for length of platform, a fixed effect for how often people talk about freedom and human rights anyway. And then let's say the position of the party, we call it theta, and the position of where freedom and human rights is, let's call that beta. And then the sigma there is going to be the inverse of how wide that quadratic is. Now, in one dimension, we sort of can't see it. There's no way to independently really say how fast your tendency to say freedom and human rights falls off as you get away from a party's position. Normally we would it's just a multiplier on one or other of the position or the of theta or beta. So it's kind of been ignored, but in multi-dimensions this is going to matter. So this is why I'm spending like a little bit of time trying to explain why what this thing is doing. So the nice thing about this model is that if you came to text analysis and you saw the equation on the bottom by reading Slaypen and Proksch, then what you're really doing is assuming the equation on the top, which is the quadratic assumptions. And that means that if you really liked spatial voting, then you're really going to love spatial talking. That's the situation where we don't just say we don't just vote for the status quo or the new thing in the roll call. We can actually vote for, that is to say any number of things, including freedom and human rights. Okay, so that's where we are in one dimension, and the tricky bit has in some sense been swallowed up. This this actual width of the quadratic utility. Okay. Happily, it's actually fairly straightforward in a rather blunt mathematical way to just add more dimensions to this model. So how would we do that? Well, rather than just having one theta, a scalar position, and a scalar position for the thing you might want to say, let's just have m of them. So if m was 2, then we're going to get two theta numbers. Those are going to be the position on the first dimension, the position on the second dimension. And we'll just stack them all up, and they have a sort of aggregate effect on how often you're going to see this word being used by that party. Sometimes one dimension is going to be driving that usage, and sometimes another one is, depending on what the betas are and the thetas are in each dimension. And now actually that sigma thing there, the weight on like how important, how fast your tendency to how fast the distance in that dimension matters to how often you say this thing is going to vary, and it can vary by different dimensions. And that's one way to make sense of there being important dimensions and not very important dimensions. Important dimensions are ones where distance in that dimension is relatively unrelated to how often you say something. Okay, this is the row column M association model, the multidimensional version of the RC model, which is the one-dimensional thing that you saw before. But basically, it should look the same. It's like, yeah, this is kind of my scaling model, but only more so, which means it's the quadratic model, only more so in 2 dimensions. Okay. One thing that's going to be important for later about this particular model and this particular setup is that we're thinking about the positions of parties as parameters, so one-dimensional, two-dimensional, m-dimensional, and the counts are going to be Poisson, or they're going to be multinomial, depending on what you condition on. But one thing about it is that if you make all those assumptions, then these dimensions that I've been talking about can't vary freely. They actually have to be orthogonal. That is to say, I can't, if I want my economic left-right and my social left-right to be in some sense correlated, which is probably what we think they are in real politics, then these are not the parameters we're looking for. So they are going to be true axes, and we're not going to be able to do anything about that. And that's a particular quirk of there not being anything to vary to make the rotations work. If you have intuitions about factor analysis, then first of all, I'm sorry, you can get therapy for that. But if you have intuitions from that particular mode, then they're wrong. So if you were doing a factor analysis of something, then the measurement assumption that you're making is what we might call dominance rather than ideal point structure. So it's not distance, it's how much of a thing. If you were thinking about IRT models, then your ability could just go up and up and up. That's just the end of it. Whereas here, we have an ideal spot that a word really wants a party to be to maximally talk about it as much as possible. Also, in our factor analysis analogy, you may be thinking that, well, okay, I've got all these dimensions, but I can kind of rotate them in questionable, exciting and illuminating ways. By messing with the covariance structure and the factors and all that kind of stuff, but there isn't any covariance structure here, so that's it. All we can do is take a diagram in 2 dimensions and rotate it one way or rotate it the other way, and that's it. It's as much as you're getting for simple structure. These aren't just what I'm going to argue later is these aren't just like quirky features. These generate very particular problems and solutions. Okay, so there's our positions. You probably haven't seen one of these things in the wild. It's quite hard to find an example of a multidimensional scaling model for text. It's quite easy to find it for other things. And you might ask, well, come on, I mean, this is just like there's an M sum rather than something else. Like, why not? And if you've actually tried to write one of these things, that's because they're horrible, like horrible things. Don't really want to fit those things. They're also kind of unstable. And they're unstable when the dimensionality, either of the dimensions or of the things that we're looking at, in this case words, are high, and we are always in high dimensional word land when we're thinking about text. So if you really like that kind of thing, then again, therapy is an option, but also GNM or logmult are good packages for doing this. You can test out that instability and excruciating bit yourself. Thankfully, the good news is there's a cheap approximation to this. This is actually probably the last piece of good news I'm going to give you in this talk. Then we can think about this. Let's switch to probabilities rather than rates. So what that is saying is, if I randomly start reading somewhere in this bunch of manifestos, then what's the chance that I'm reading the FDP saying something positive about human rights? And the answer is, well, it's partly the probability of reading anything by the FDP and probably the probability of reading anything about human rights. That's the independence model that you see in the two P's on the right-hand side. And then there's a multiplier which kind of boosts that up or drops that down relative to what I'd expect by chance. As a function of these parameters over here. I put little twiddles on the top of them because they're not the same parameters as last time, but you know, they kind of are actually. So this is correspondence analysis. You can think about it as the previous model in multiplicative form, or alternatively, you can think about the previous model as this model in log form. And basically, it's cool because one singular value decomposition of our data, mildly transformed, is going to get us all those little theta twiddles and beta twiddles. We'll get word positions or topic positions, and we'll get word, document positioning, which is cool. So they're about the same for the following nerdy mathematical reason. If you want really the detail there, then I recommend reading that ancient paper by Goodman. But as we go forward here, I'm just going to assume that these are basically the same model, one loosely approximated by the other one. Everything I say about one is really going to apply to the other one. So great, this is the good news. We have a cheap, we have one SVD will get us all kinds of cool plots in multiple dimensions, which we apparently want, subject to these orthogonality constraints. Excellent. So we get this lovely diagram, which many, again, if you've seen my slides before, then you'll see my absolute favorite picture of German parties from kind of 1990 to I think 2008, if I remember rightly, but in two dimensions. And so the eagle-eyed amongst you will notice that if you project all of these triangles, the party manifestos, straight down onto that horizontal dotted line, then you'll get pretty much the ordering that you saw on the previous slide. So the first set of positions is just that, but we've got this extra dimension up on the vertical, which is separating out, say, the CDU from the FDP. For whatever reason, we can say why, and indeed it's on the graph in this pie plot. But what I don't want to, I'm not going to be too substantive today, so I'm just going to say, hey, look, variation in dimensions, excellent. We've got a second dimension, and then we can argue about what it is. So far, so good, I think. That was kind of that was where my last bit of thinking stopped before I started thinking about something else. So let's consider interpreting this thing. So we now have as many dimensions as we can bother to do an SVD for, which is all of them at once, so we can have as many as we like. And then we're going to figure out what we're looking at. And this is where actual multidimensional scaling becomes a problem. Okay, so I'm going to say a very little bit about the familiar trouble, that is to say the trouble you should expect to find when you have multiple dimensions in an exploratory model like this. And then I'm going to talk about, hopefully, what is unfamiliar trouble, something that you may not have run into before, but is kind of alarming. Okay, let's consider the familiar trouble. And this title is purely for Thomas Deubler. Hi, Thomas. What you're looking at on the left-hand side is courtesy of Ken Benoit, I think, at least I got it off him. If one of you did it, thank you, is a bunch of scaling. There's estimated positions, and there's a whole bunch of speeches by people. These are, in fact, Irish budget people, right back to the birth of the Republic in 1923, up to 2009. And what you're, I guess, seeing here is, here's a whole bunch of people who give speeches, and we can think about looking for the major single dimension that identifies what they're talking about. And that is here kind of obviously when you lay it out like this. It's just time. This is not a multidimensional plot. This is a single dimensional plot, which happens to have been displayed in this graph according to the secret covariate that is in fact driving the whole thing. So what this is making clear, I hope, is that what you're really seeing when you scale all these positions is a time scaling rather than a ideological or a financial or something like that. And this is actually a pretty common problem. The first dimension that we get isn't what we were expecting. In this case, if you're a political scientist, then you might be quite upset that that you weren't getting ideology. On the other hand, if you were an archaeologist, you would be very happy because that's actually what you do ordination for. And indeed, you use the same model. Okay, so standard problem. First dimension is not what I want. Maybe I wanted that more complicated model so that I could get this other bit. See, there's a little bit of variation around there. That presumably is everything else that isn't time. But let's unpack time a bit. It sounds more epic than it's going to be. So why would we generate this effect? So one way to think about this mess here is that there's a whole bunch of things that everybody from the birth of the Republic upwards talks about putting in the Irish budget. We can call those core budget items. And they're consistent. They kind of keep everybody on the same page. And there's also a bunch of year-specific items. So presumably buggy whips are down there on the bottom left, and IT equipment are somewhere in the top right. And nobody talks about the other one at the other end of the temporal scale. And so we have these kind of year-specific bundles of things that are in the budget. So if we're actually interested in ideological positioning, then we sort of know that we have to really condition on what the budget is going possibly to talk about, and then say, okay, who's left and who's right within this bunch of items. But actually, the scale is so long that the items are sort of constant. There's a set of items that are constantly changing. Now, if you read the ecology literature, then they call this a long gradient. In particular, we can think about gradient length as being the turnover of stuff that gets talked about over time. And a long gradient is where, we'll be a bit more detailed about this, but a long gradient is one where the classes or the bundles of things that are being talked about at one point in the scale, here it's time, but it could be ideology, are really end up being disjoint from the ones at the other end. Okay, so that's a familiar problem, I think, and we know what we're doing when we see that, and you've probably run into it before. Let's talk about an unfamiliar problem. And for that, I think we should go back to the quadratic assumption that I showed you before and say, what would the Platonic form of unidimensional scaling count data look like? What would be nature's own document term matrix? Let's say it had 11 documents and 19 things it could talk about, 19 words, 19 topics, whatever. Then maybe it looks like this, where if it's 0, I've just dropped a dot in there. So you can think about that as the first 9. So the 9 words are used in the first document. Most of all, this one uses the 5th one. There's the 8, and it doesn't use 10 through 19 at all. And the next one, in purely kind of ideological spatial sense, just shifts along a bit. Now it really likes its ideal point is in some sense whatever the ideal point of word 6 is. And then so on downwards until eventually this is in some sense a very rich party system with very fine-grained distinctions in ideology, which completely tile the possible space. So wherever you are, there's a party really, really quite near you in some sense. Okay, so that's essentially what underneath it would look like, in the sense that that represents the quadratic assumption. So document 4 says topic 8 most of all, and 7 and 9 about equally much, but not quite as much, and so on. That's minus the noise, and this is going to be helpful here to think about what happens when we just don't even have any statistical problem here. This is pure model. So let's say we didn't actually see the forms, as one doesn't, I'm told. Maybe we should actually fit a multidimensional model and ask ourselves whether, like, what kind of things are going on in this data if it wasn't quite so neatly arranged. So what would we get? Let's do that. So first of all, let's have a look at what passes for model diagnostics on a scaling device. Apologies for anyone who actually knows what model diagnostics are. These aren't them. But one thing we could do is ask, okay, let's fit a multidimensional model and ask how much of the variation in counts is explained by the first dimension, and then the second, and then the third, and then the fourth. And if we look at that, then we can read this from left to right. And it looks like about 55% of the variation in the counts are explained by the first dimension, then yeah, kind of a little bit less by the second, and somewhat less by the third. This should, I think, set alarm bells off for you, because there is no second, third dimension in this data, kind of by definition. That's how we've arranged it. Right? There's just movement in the ideal point across one dimension, and that's it, and there's not even any noise. So what do we look like? What do things look like if we fit one of these multidimensional scaling models that I was previously very enthusiastic about? Well, first of all, they look like that. There's dimension 1 on the bottom, duly taking up 53% of the thing. So good. In some sense, these are equally spaced. And so those red dots are where the documents are. The unfilled ones are where our equivalent item scores. So there's 19 of those. They're all in the same space, and you can kind of see how they line up. If we flatten them all down onto that 0 mark, then we get a familiar sort of scale. But if we allow the second dimension, then we get this crazy structure here, which apparently is fairly substantial, right? So it's like 30% of the variance that we see is actually explicable by there being a second dimension, which, by the way, we know there isn't. Since we're making a mess, we should continue to make a mess. So let's fit 3 dimensions, and so the third dimension is kind of a roller coaster, connected to dimension 1 this way, still 11% of the variance there. So apparently that was worth putting in, except obviously that's bananas. Okay, cool. Then there's a fourth, just in case you hadn't got the point yet. And at some point, we don't in fact draw the elephant, but it kind of begins to feel like it. And then finally, we might ask how these secondary dimensions that we kind of know don't exist, how they relate to one another. Whee! Yes. So I think this is kind of, you may be having this sort of response to that. Yeah. So there's a problem, or potentially there's a problem. Or maybe we're learning something deep about there really secretly being extra dimensions in this data, but I'm pretty sure we're not, because we made that data up ourselves. Okay. So what are we looking at here? We are looking at what is in various literatures referred to as the arch, or a horseshoe, or the Gutmann effect, if you read the French literature. And there's a couple of other names for this. But if we concentrate on that second dimension, then this is the arch structure that we get, a quadratic relationship between the first and the second dimensions, which is, I think I've made the case, is entirely spurious. So if you want some intuition for that, then here's approximately how the intuition goes, and I'm not promising that it's amazing. Scaling models are low-dimensional reconstructions of chi-square distance in this case. So we're actually, for our 11 documents, then we've got, they have distances between them, and we are approximating those distances, and also for the items, but document distances, in terms of a 2-dimensional plane. So this is a sort of form of metric multidimensional scaling, as many of you know. And the problem here is that the distance relationships are a little bit screwy when we have ideal plane structure. In particular, the words are more distant the fewer words or that they have in common, and the less they emphasize them at the same rate. So in this particular story, that first and last document you saw don't share any words. So they're maximally far away. On the other hand, if we sort of kept the scale going, then everybody will be exactly that far away that didn't share any words. So they'd all be the same distance apart, despite the fact that on the real dimension, they're getting further and further apart. But we can't tell because there's no overlap. If you want to think about other intuition here, then, okay, here's a model that has a first dimension, and for some reason, we've asked it to give us a second dimension. And the constraints of the optimization procedure are saying, look, give me the maximum distance between these documents, but keep everything orthogonal, because that's how our dimensions are going to go. So it does, which is most easily done by taking the first dimension, then folding it in half, which maintains orthogonality and generates bit noise. And bang, we have a second dimension, so quadratic. So what do we make of all this? Well, first of all, we shouldn't we shouldn't panic quite as much as I might have been doing a little while ago. This is an artifactual structure, I think. And I've kind of shown it most clearly when there really isn't any extra multi-dimensions in this thing. There's only really one dimension. So if there is actually extra structure in other dimensions, then what we'll get in the classic kind of regression coefficient under confounding situation, we'll get a mixture of the right position and also some other stuff, which is spurious. So that's something to bear in mind when, for example, you're reading Journal Politics and seeing like this beautiful arched kind of structure from Koenig and colleagues, and then interpreted as definitely two dimensions. So there's a question: how much of this is true multidimensional quadratic structure? How much of it is a spurious accident from having a scaling model that has these sorts of assumptions? Hard to say. I don't want to make any particular claims about this one, but I want to point out that there is some reason to believe that you may get that structure even when there is, as it were, less of that structure in reality than everybody's expecting. Okay. If Thomas is in the audience, we love you, Thomas. Okay. So how does this work? So I'm going to be, unfortunately, a little bit sort of qualitative here. I would like to give you a kind of a decent mathematical theory of this thing. But first of all, no, you don't want me to do that. But second of all, it's actually fairly easy to show at least qualitatively what's going on. So this quirk, this mayhem that happens in the extra dimensions, it's kind of a function of overlap, as I tried to say before. So here's two documents. I've just sort of narrowed it down to two. And we're going to measure the overlap here by talking about how far away their ideal points are. And I'm just going to say their ideal points are exactly where they ought to be. So the thing you say most is where the ideal point is. So there's a first document that says 5 most of all, bold-faced the 8. That's what it says most. But the one underneath, it peaks at 11, which means that on this somewhat arbitrary scale, they're 6 apart. For the purposes of like generating data with no noise, this is fine. So that's 6 apart. You saw previously a situation where there were only 1 apart. Okay, so let's fit a whole bunch of models where they're 1 apart, and then they're 2 apart, and then they're 3 apart, and all the way down to where they're 8 apart. I want to draw your attention just to the top and the bottom line here. What we're looking at is how much variance is explained by the first, second, third, up to 10th dimension. And we'll look on the first one as what you saw before. That's our arch, 55% on the first dimension. And then it sort of fades out until almost nothing is going on in any of these so-called higher dimensions. If we go all the way down to the bottom where the overlap is shrinking and shrinking and shrinking, then we'll see that the first dimension is the right one. So 10-ish% of the stuff is going on in the first dimension. But actually, all the rest is going on in almost every single other one. So this is no longer privileging the correct answer very strongly because there's an almost as big bunch of secondary structure and tertiary and quadriterary, or whatever the right word there is in English. So we're generating more and more spurious structure down the kind of tail ends of where the dimensions are. And that's just my way of saying the longer this gradient is, that is to say, the closer we are to minimal overlap, relatively well-spaced, somewhat distinctive vocabulary type parties, then the more we are likely to generate this spurious structure in second, third, and fourth dimensions. Okay. So what are we going to do about this? Well, first of all, we're going to read the literature because that's what we do. And if we do that, then we discover that most fields that have a scaling model, which is a lot of them, know that this exists, which is faintly embarrassing, but okay, now we do too. And most of this stuff is in ecology. That's why I'm talking about gradients and ordination and all that kind of stuff. But a bunch of it is in applied statistics. Those are two good illuminating sorts of papers on it. That's Percy Diaconis there. But what's kind of problematic for us is that it's surprisingly inconclusive. So everyone agrees that there's this thing. They have some view about how you generate it, and then not too much of a view about what to do about it. What I want to suggest here is that for those of us who are interested in scaling text, a very specific sort of problem, then I think that we should expect that these kind of phenomena should turn up a lot. And the reason we should expect they should turn up a lot is basically because Zipf's law. So most of the counts of words in documents are 1 or 0. Like that's actually kind of the bulk of our document term matrices. So a general state of it's kind of the state of the data. It's not even a problem. It's just how it looks. And what that means then is that if we think about overlap, then we're almost guaranteed lack of overlap, just by virtue of just hardly ever seeing most of the words most of the time. And that's going to give us, in some sense, long gradients almost by design. So that then suggests that we're going to get these effects. That's again not a particularly rigorous argument, but I want to suggest that at least as a hypothesis. Okay. One reason to think that is actually what's happening, and again, not super conclusive, but let's do a compare and contrast. We will take those same German manifestos when we look at them as in terms of the comparative manifesto project categories, of which I'm going to use like 56 of them, or in terms of the actual words that are inside them, which are going to be about 9,000. I'm just going to use Slopen and Proksch's data here. So pretty much the same parties, not quite exactly, but it's not going to matter for this. Two different versions of them scaled. One thing that and the argument here is that overlap across mentions and categories is going to be much larger in the comparative manifesto set because these categories are bigger and almost no one never talks about the topic, whereas quite a lot of words are only used by 1 or 2 parties and never by anybody else. So we should expect that sort of data. So if we run 2 models and compare them here, we're just comparing them in terms of like multidimensionality in some sense. In the first one, if we're looking at topics in this short gradient, not a fairly overlapping set of items, then we get this kind of characteristic fall off. There's a main dimension, there's a secondary one, and then it sort of drops off. But if we look at words, and there are of course a heck of a lot more possible dimensions here, but we get this very like structured approach. So sure, there's a first dimension, but the second dimension is allegedly almost as big, and the third dimension almost as big as that. So maybe there's real quadratic structure, but there's also like a ton of, in some sense, artifact in here, probably. Disentangling it, yeah, that's a separate question. But this is some sort of qualitative reason to think that this is what you get when you scale words, and it happens somewhat less when you scale things like topics. Okay. And one, I guess, since we're going like fully qualitative, let's have a picture. If you scale the words, then you get a structure like this, which on the one hand looks kind of archy, but on the other hand does rather reflect, at least in most of its FDP, except in most of its FDP placement, where everybody was in the previous version. So in this case, we're presumably seeing some convex combination of arch artifact and actual like multidimensional structure. But who knows? Okay, so that's enough. It's enough hand waving. What do you want to do about this, or what maybe should we think about doing about this? So we can divide these things in the usual way for methods problems. Methods problems are like grief. First of all, you deny the problem exists, then you get annoyed, and then you bargain with it. And then you reduce your expectations and try to do something a bit smaller. And then finally you say, yeah, that's kind of how it works, or hopefully you do. Those pretty much line up with what we can do here. So we can avoid it. So we can scale up, we can use the CMP, we can use topic counts rather than word counts, all the while trying to sort of shorten and overlapify these gradients that we're getting. We can just get annoyed and try to remove it. In the ecology literature, they call this detrending, which is basically rather manually removing the quadratic effects and sort of flattening everything out. That has some viable critiques in this Wartenberg paper, and I'm not going to talk about it any further because it's a statistical fix kind of approach, which I hope you are somewhat allergic to. Perhaps more interestingly, we can talk about adding constraint. So this speaks then to the substance of the domain. This is where we might actually hopefully add some of our substantive knowledge and also fix a problem. So by constraint, I mean we can add information about document positions, or indeed we can choose items in a way that makes sense to us. There's various ways to do that. We're going to talk about those somewhat briefly. And a very similar strategy is what we might call agenda control, where we say, actually, let's just kind of start in the political science and end up in the statistics rather than starting in the statistics and then try and add the political science. So maybe we should actually start looking for individual substantively meaningful scales one by one as we want to find them, and then make the stat work. That's the kind of the Wordscores approach, but also some others. Okay, those are the possibilities. So what I want to do in the final kind of maybe 10 minutes here is, if I'm lucky, is talk somewhat more generally about how we might get the scale that we want, on the assumption that the scale we want is we want the social dimension, or we want economic left-right, or we want pro-anti-EU kind of things, or whatever it is that we actually want out of our scale. So how would you get that? So one very basic observation here is that scales are defined by their items, by the words, the topics, the questions in the survey, whatever, and their loadings. So like how much you take these things into getting document positions. So what's really kind of unique about the text scaling problem is that if you're running a survey, maybe you put like 5 items to talk about, I don't know, economic left-right or something, and then you're kind of happy and you generate an index or you do some fancy IRT thing, and then you're like, yeah, okay, 5, that's okay. If we use a topic set, so a collection of topics rather than words, then yeah, maybe 140 or maybe 56 main categories from the Marpor people, or maybe 26 if we just think that their RAL categories are good enough, or maybe 2 if we're a bunch of sentiment analyzers and we just want kind of positive and negative and then some scale in between. If you're me, then you've got German manifesto data, which means you have 9,000 possible items. And you are, in fact, these cats. Survey cats have 1 or 2 balls to play with, and text analysis cats look just about as happy about having 9,000 items to choose as these cats here. What's also kind of interesting is that because this is such a problem, the text scaling field generate some kind of novel, rather indirect ways for choosing and like putting numbers on the items that it's going to count to make scales. So the uninteresting ones are where we just choose them, and the more interesting ones are creative forms of sample selection. So let's talk very briefly about those. I think the indirect ones are kind of interesting. So let's think very loosely about a typology of item cats strategy. So how are we going to choose items? How to be the big claw that pulls out not all 9,000 of them, but maybe just the ones that we want. So we can think about this as choosing items or loading them, that is to say, weighting them somehow. Obviously, if you weight them to 0, then you've deselected them, you've dechosen them. And we can do this various ways. We can do it automatically. by estimating things with models in the way that I've just told you. Or we can do it manually by simply asserting that every time I see that word, then bang, up one for some dictionary category. That's the kind of RILE strategy for these things. Or you can kind of mix and match these strategies for choosing items. So far, I think not so unusual. I mean, we do it, the survey people do it. Other people, other fields who scale stuff also can choose their own items. That's cool. What's more, perhaps possibly more promising, but certainly something that other people can't do, is to use these indirect methods of deciding which items, which words, which topics you care about. So this is what I generally refer to as the life-changing magic of changing the unit of analysis, something you can always do and sometimes helps. So I guess one of the original examples here is Proksch and Slapin saying, okay, well, maybe you want economic scale. Okay, cool. How do you get economic scale? Do you want to choose items? No, way too many words. But this is a German manifesto, let's say a party platform, which means that it has probably 2 volumes, 16 chapters, and a detailed kind of list. So it's actually fairly straightforward to go in there and like pull out the sections in economic policy. So what we're doing is essentially redefining what document is. And so we're going to rip out everything apart from these sections and say, that's what I want document to be. So that's the unit of analysis. That generates, shall we say, indirect control over word appearance, because if you don't make it into those sections, you don't make it into the analysis at all. And indirect control over frequency, that is, only relative frequencies in the right place matter. And ideally, it gives you control over dimensionality on the assumption that the sections that you choose are all on the dimension that you're interested in. So in short, you can scale the trench coat, but sometimes you need to scale the raccoons. Just briefly while I'm here, this really is a life-changing magic of redefining the unit of analysis. This is so if let's do it more extremely and then get back to our main track here. Think about constructing a Word document. That is to say, a document which contains every single one of the keywords of context for some word J. So every time you use the word and its local context, let's dump it in a document and say, that is the word J document. It's basically the quick. So then you say, okay, I've got a lot of these. There's really a lot of them, one for each word. And I'm going to fit some scaling model of exactly the same kind that you saw above, hundreds of dimensions in this case. And then when I get that model, I'm going to take the quote word items out of it and the document items out of it. And those are going to be scores. I'm going to average them and say that, gentlemen, is the position of this word in like the space of language or whatever. Now you can do this because this is effectively a co-occurrence matrix of words, the documents containing only uses of that word in their local contexts. And so it's completely symmetrical. In the sense that if A is 20 occurs 16 times within a window of B, then B occurs 16 times in a window of A. And so this is a symmetrical matrix that we're scaling. And the claim here is that the multidimensional position of these newly defined documents is in fact a word embedding for that document. And indeed it is, because what I've just described to you is glove. So if you were wondering what the life-changing, the magic of changing the unit of analysis is, then yeah, sure. If you read the glove paper carefully, then you'll discover that it's multidimensional text scaling applied to a slightly quirky definition of document. But let's get back to the main track here. There's always an irrelevant aside, and that was it. So you don't have to worry about it anymore. Other things we could do about indirect methods, which I think are more promising, but I'm going to say less about. We could add information about document positions. So principally, we could do this to Wordscores, which you've heard about, but there's a whole pile of related methods that we could also talk about. Or you could just simply assert what the document kind of positions are. Or you could say, I know some things about these documents, who wrote them, what kind of party they are, all that kind of thing. And I'd like my positions to live in that space. So constrain the final space that you get by a bunch of covariates, not by just the word usage. Let's consider these things. So what we're doing really here is considering document positions as magnets. That is to say, we want them to draw right sorts of item parameters to themselves. So if we set the documents right, they'll inevitably draw the right word scores, as it were. So while we're thinking about word scores, let's ask the question, which I can't answer. Word scores, how do they work? Unlike magnets, I think we don't know how word scores works, but here's approximately what we're doing. And if anyone has a more sensible idea about this, then that would be good. But this is one of the hopefully promising ways to get at a single particular substantive dimension. So if we knew how it worked, then we might know how seriously we should take it more generally. So we have two reference documents, let's say. Let's score them -1 and 1 for the sake of argument. Then words that occur in those documents are in the item set, and everybody else isn't in the item set, even if you occur all kinds of other places. And then we're going to put loadings, the word scores, so-called, for the vocabulary in these documents as whatever numbers it takes, such that when you average them within each document, they get those -1 and 1 positions back, or as close as we can get. So give me the scores which recover -1 and 1 for these two things. If a word is non-diagnostic for which document it's in, it's going to end up near 0 because you just can't tell, and the average is not going to affect the average. Okay, then we're going to take those and apply them at a sample. That is indeed a special case of the row association model. So the question is, yeah, we can kind of describe how that, like concretely, how we do that, but why does that work? So I think the intuition is basically, what do we have to assume? Well, maybe we have to assume that all the variation on the dimension of interest is kind of embodied by these two documents, both in terms of what words they use and also how important they are. And that the dimension is driving the word choice and the word rate. And then the scores are just reflecting those two things, which means then we sort of have to assume if there is another dimension floating around in this document, then it's in some sense orthogonal, otherwise it's going to mess up the word scores. So I think there's an orthogonality assumption in here. And there's also a thing where you select the words by virtue of selecting the initial document, which is a part most people don't really talk about. We also don't know what happens really when there's more than 2 reference scores. So yeah, who knows? I don't know. I think these are open questions. If we could answer these, then we might have a quite nice way to or I would feel happy using this tool to get exactly the substantive single dimension that I want. And I'd use exactly the same documents, somewhat magically, to get a different dimension, however that's meant to work. Okay. Yeah, open question. I guess finally, the last thing I want to talk about in some sort of positive responses here is we could have document covariates. So this is not particularly well known, or if it is, my apologies. We might fit this nice model called canonical correspondence analysis, which is pretty much like correspondence analysis, except that it's what you might call a structural scaling model. What does that mean? Well, if you've met a structural topic model, then the idea there is that the balance of topics is somehow related to the column space of a whole bunch of document covariates, rather than just being the topic model. In this case, a structural scaling model is where the positions that we have in whatever space we're in are actually all living in the column space of some document covariates, not just sort of arbitrarily, but they are so they're somewhat determined by what the documents think is interesting variation, and somewhat determined by actual word variation. And so in that sense, we're thinking about the column space. What's kind of interesting about this is that we can also think about controlling for document covariates by asking for a space which is made only out of the null space of the document covariates. So for example, if we had our Irish manifestos there and we thought, shoot, looks like time's a really big dimension, but I don't want everything to live in time because that's what my scaling model gives me anyway. What I'd like to do is factor out time. I'd like to adjust for it, as it were. So in that case, we could operate in the null space of the best predicted time covariate. So we would know that whatever time was doing, it was orthogonal to where our positions were. Unexplored, I think, relatively speaking. Some of you are going to tell me that you have explored it, and I'll be very, very happy. But I think relatively unexplored in political science. But like, tell me I'm wrong here. That would be great. I think it's kind of super promising, which is a sad thing to say about a paper that's from 1986. But you know, some of us move slowly. Okay, me wrap this up, and then actually I'd like to hear more from you and less from me. So dude gave a talk. What was that all about? Let me see if I can kind of summarize this. So we can fit multidimensional text scaling models. Maybe that's news, maybe that's not, but we can. It's cheap, it's easy, it's cool. We should carefully interpret them. Easy to say, but that's just like every other exploratory thing. However, there's some unexpected problems which turn up because of the specifics of our text scaling models. And those are essentially the combination of ideal point structure, which is non-negotiable because that's what we want in this bit of political science, and orthogonal dimensions in the statistical identification sense are going to generate this artifact, which is going to be worse under certain circumstances, sadly, which we can expect to occur. The solutions are, as I mentioned, sadly, a bit unclear to me. Maybe they're clearer to you. But they might include trying to avoid these long gradients, that is to say, maximizing the overlap of all of this stuff. We wouldn't even have thought to look for it if we didn't have the quadratic ideal point kind of analysis in the background. Or alternatively, we can kind of back off and say, look, this multidimensional stuff really, it's too weird. So maybe we'll go for individual substantive dimensions separately. And that's what I was trying to get at in the second half. And maybe we're going to do that by careful item selection, or shall we say by sloppy item selection, by doing something weird with the documents. So when we do select items indirectly or directly in text scaling, I think it's fair to say that it often works, but none of us are quite sure why, or at least Will is not quite sure why. And I guess finally, ultimately on both statistical kind of artifactual grounds, but also on solid substantive political science grounds, grounding out a scale in actual document covariates, non-textual facts about documents, for example, using canonical correspondence analysis, seems actually like a really good idea. Maybe we should all do that. Yeah. So with that, and with a nod to the longitudinal German election study, here are some llamas. I thank you for your attention, and I will be looking forward to your questions. Goodbye, llamas. Fire.
Thank you so much, Will. We now have a little more than half an hour for an open floor Q&A. So feel free to chip in.
Hands.
Feel free to raise your hand in the chat, or post your to raise your hand in Zoom, or ask your questions in the chat.
I hate being this guy. So Dennis, do you want to kind of organize questions, and I'll take them as they come at me?
Yes, of course.
Or how do you, any way you will like.
Yes. So as soon as we have questions from the audience, I'll be happy to give the floor to them.
Well, everyone's hand went down again. Oh dear, that's very upsetting. Or maybe everything's happening in the chat. That would be my optimistic thought. No.
Okay, so we have a question from Mario Seltzer. So Marius, if you'd like to unmute yourself and ask your question.
Oh, I'm a ghost, I think. I don't know. Well, first of all, thanks for the talk. It was super entertaining, and maybe it's just because I think a lot about scaling, but it was a very, very great presentation, I think. And yeah, I mean, I've been thinking about these issues for some time, and I've also been experimenting with the canonical correspondence analysis. And well, I'm mostly working with data that is not just textual and therefore has many dimensions because of many words, but also because it's very large data. So I'm mostly working with social media data. So I start detrending that stuff using a canonical correspondence analysis, but the problem that I'm mainly facing is that there are so many levels of possible confounders that you might want to exclude. And up until now, I only have seen models that allow to control for individual dimensions. So for example, you can get out time, or you can get out geographical clustering or different languages or whatever you want to do. But I've never not seen anything that would allow you to do this in a sort of multivariate model. Do you know anything about how to generalize that towards including like a regression model?
Well, yeah, so in some sense, for those who haven't met this model before, the canonical correspondence stuff really is a regression model where you don't see the dependent variable, but you know that it's made up out of scales constructed out of like text counts. So it's in some sense a scaling model attached to the end of a regression model, CF, the structural stuff. So one of the maybe I don't know how helpful this is, but one of the sort of sad observations about putting positions in the column space of some things that you know about documents is that if you know enough about these documents, then you put no constraints over what the scale could be, because that's a really big space. And so actually you get the same positions as you would just from the text, which can be sort of disappointing because you like to do that. On the other side, where you're trying to control for stuff at the same time, I am extremely unclear about how that goes. Like I do not feel like I have a good sense of, okay, I'm in this null space, but this column space, and there's like some influence of what I'm trying to, of the positions I'm trying to predict, but they're only indirect from these word counts. What am I looking at again? I don't know what I'm looking at. So yeah, let's put it this way. I feel your pain. There you see, that was deeply unsatisfying. No, it was like a whole like wasted talk because you thought you might be.
Well, sometimes it helps just to feel seen.
Yeah. Well, in some sense, I don't know how much of this audience has run into these models at all. Just to get you to practice to put your hands up, may I ask? And you could kind of stick one of those little yellow jobby hands up if you've run into this tool, or is it just Marius? And Daniel.
Marius made me do
it. Okay, right.
We did it for trying to get positions for UK MPs for Twitter, and we were worried we were getting a bit of clustering by the particular committees that MPs were from. And we wanted to add in information that we weren't getting the separation across parties we thought we might be seeing because there's commonalities in the topics they'd be talking about. So we got a whole matrix made up of all the different committee memberships of members, so we're able to sort of weight or detrend that. It made absolutely no difference at all, pretty much.
Okay.
It works time. For time, it's actually you get this gradient out of the data quite nicely. If you take the date as a canonical correspondence as a covariate, that works. But yeah.
Right. I'm assuming kind of substantively nothing correlates nicely with time apart from just change. So like you're just tracking overlap. So yeah, I would worry when you're trying to get something out which is like covaries nicely with something you actually care about, and then you're going to orthogonalize it and get and yeah, have your positions eaten. It is kind of I just want to note something kind of striking about this. I'm not quite sure whether it's relevant, but if you were to take those overlapping things and then stretch the gradients so that they really are like they have separate vocabularies in some sense down either end of this ideological gradient, if there's no overlap at all, then you're effectively fitting a topic model, which is one of the reasons that you can start fitting a topic model with a so-called what they call it, spectral method, which is basically like run one of these darn things and hope that it looks like that rather than have that as the problem. But yeah, what I was sort of hoping everyone would tell me was, yeah, we know about the arch and like here's the options. But yeah.
Well, I have seen the arch.
I'd also quite like someone to tell me how Wordscores works in a geometrical sense. That I don't quite see, but
there's this really good paper called Understanding Wordscores. I'll send you after.
Yeah, is it one of those ones where they have a really great title, but it doesn't actually do that? I hate those papers. Yeah. Yes. I guess it isn't called an understanding of Wordscores. It's just like, let me tell you about the process. Yeah. Yeah, so I'm not quite sure I do see that. Anyway, yeah, so I started off this whole thing thinking, hey, I look at this awesome multidimensional extension of exactly the same logic that I we have before. Isn't that great? Ideal points, aren't they fantastic? Political scientists love them. Like this structure, like what's to go wrong, right? And then literally everything that has this ideal point structure ends up with an arch in it. So like this text scaling does, but I think de Lowe at some point has like a paper called an arch for multidimensional scaling. I'm like, damn it, I was going to do multidimensional. Okay, fine, right, not that then. So maybe I guess the optimistic picture is, hey, this is kind of interesting, and this is what you do about it. And the pessimistic picture is all of those people who are at the back of the seminar room being skeptical about your claims about multiple dimensions, particularly from text, but maybe from other things as well, are maybe probably not the grumpy old loons that they, in fact, also are, but not just that. Yeah, so I ended up slightly skeptical about these things. It's entirely invidious to pull people out of the audience, but and ask them questions. But because I know he's such an easygoing guy, I was going to ask Thomas, who thinks about these things a lot, whether he had any great thoughts.
Are you talking to me?
You, sir. You don't have to have. I mean, feel free to duck out. I don't actually mean to put you on the spot. I just put you on the spot.
Well, first of all, thanks for the very interesting and entertaining talk. Second, perhaps as a disclaimer, I'm perhaps not so much a text as data person anymore, if I ever was one. Well, anyway, I mean, one thought that I had was, so if I understood it correctly, the arch problem has a lot to do with overlap, and that has a lot to do with excess zeros in your data.
Seems like that. Qualitatively, seems like that.
And one way of addressing that excess zeros problem would be to run a model that takes into account the over dispersion, because the excess zeros and over dispersion, they seem to be very closely related. So I was wondering if we use tools that address over dispersion, like for instance using a negative binomial model instead of the Poisson, could that possibly alleviate the arch problem then?
It's an interesting question. The reason I asked was I hoped you would bring up a nice new paper which involved a negative binomial. So yeah, indeed. And also would know the answer to that question. That'd be great. But yeah, so I don't know, but that's like changing so the question would be changing the distributional assumptions. Would that help any in some sense? I have this feeling that as long as you have this log link that like the dispersion stuff isn't doing any work because we can't rotate it or like do anything with it. It's just kind of there. But maybe that's wrong, and maybe we should think about like other distributions. Yeah, indeed.
And perhaps one other thought I had was, I mean, I guess some people would probably make the point that, you know, we shouldn't really estimate what we know already. And I guess that is perhaps a question that sometimes pops up here when you look at party positions, especially because, you know, we have all these expert surveys and vote advice applications and whatever. So we really know an awful lot about party positions. So when we look at text, should we always approach it like from scratch, or, you know, should we should we really carefully think about what the extra bits are that we want to infer from the text that we don't know already? And I think that sort of seems to overlap with the points you make about, you know, adding prior information and structure and so on.
Right. I'm thinking particularly of this Koenig-Marbach kind of collection of work, which says here's an enormous prior from experts, and then here's what, and then we use the CMP data and it changes things by like, and then you think, okay, what were you doing that for? And like, where's the win here? Or at least maybe I was the only person thinking that, thinking, what a lovely prior. Why don't we just have that as the posterior? That'll be cool. But yeah. Yeah, so on the one hand, I want to say that's surely true of manifestos. They're in some sense the hard case, I think, for this, because a lot of other text data comes pre-topicked, and so the multidimensionality pressure is weaker in the sense that you know the manifesto has to like hit all the points, whereas if it's if you've already like pre-topicked it, then yeah, this sort of stuff doesn't really, like you're just using a neat tool to get fundamentally one-dimensional stuff. But indeed, point taken. The examples are what they are in this talk, certainly very largely because I'm in Mannheim talking to Mannheim people, and for some reason everyone's super interested in elections. I hear Germany's just had one or something like that. But yeah, which of course means I should have used its most recent ones, but they wouldn't have been as pretty. Yeah, fair enough. Yeah, so maybe call for a bit more modesty. I mean, one of the things that this might say is, yeah, you can't trust anything other than one-dimensional anyway. This is sounding very much like a formal theory talk, right? It's like, yeah, here's a bunch of beautiful results which only work in one dimension, and now I have chaos theorems. All bets are off. In kind of, add a couple of dimensions and you're screwed. So it would be unfortunate if things look like that in the sort of like free form scaling land, but maybe that's what they look like.
Sorry. Hi, Will. I also have a question for you. And it's about the relationship between topic models and scaling methods in a way, or whether you can use one to also end up with the estimates for positions. So this is based on a conversation that I previously had with Marius, that a lot of the positional estimates that we use in political science are essentially salience-based, in the sense that it's some function of the frequency of positive mentions and the frequency of negative mentions. So in the simplest case, I guess you could devise a topic model using some supervised classifier that tells you, well, is a certain document topic A or topic B with certain probabilities? Does it have positive mentions on each of these two topics? So you end up with a 2x2 and you have a joint probabilistic classification of the probability that the document belongs to one of these four cells, which you could then, I guess, use post hoc to construct a scale on each of the two substantive dimensions that you're interested in. So do you think using this different infrastructure or this different this different form of device is a feasible way around the problems that you've sketched here today?
Sure. So I mean, maybe Wordscores had it right, and or indeed the Proction, some other dude sentiment analysis thing. That maybe actually what you want to do is basically like topicize this thing first. So find a situation where you know that you're only arguing in one dimension, and then scale it. And then pick another one and then scale that, and then ask about how those dimensions sit together. That seems entirely reasonable. I should, for those thinking about like design, like methodological design questions here, one thing that interests me is that you can put scaling both below and above topic models in an interesting kind of way. So if you want the scale above the topics, then you can say, look, I'd like some low dimensional structure across all of the topics that I'm about to infer. Thank you very much. And that's going to get you essentially something which is a correlated topic model. So that's going to essentially scale the topics, or you can do it explicitly in the structural sense. So then the topics are the things being scaled, but it's also perfectly feasible and probably substantively more useful if, however you determine what your topics are, you first of all decide what they are, and then within them like fix your scales. And I think that if I remember reading it, if I remember reading it at all, that's the Gamson-Modigliani frames model, where you decide like how we're going to talk about it, and then you decide whether you like it or not, as it were. There's like a kind of a split then continuous measure kind of thing, and that's sort of the internal structure of the frame. I'm now going to kind of fade back into the hedge as someone who knows actually something about frames tells me that's wrong, but that's at least how I remember it. So yeah, the main point here was one of the open questions is where do you want these topics and where do you want these scales? And yeah, there are interesting choices, options. The other thing is, I guess at some point that discussion becomes sterile because you've only got the term document matrix and maybe some other stuff to work with. So whether you're kind of forcing topics into it or forcing scales into it, at some point they really become the same thing. Like there are circumstances under which you're basically seeing topics or basically seeing scales. One of the nice older examples of this, I guess, is the discussion in EUP a while ago about whether like radical populist parties are they on another dimension, or are they like, something different? You're really asking, is this a topic question or is this a scale question? And at some point that's not answerable, right? I mean, there's, except by assertion, you can see them either way, and no kind of variance explained argument is going to tell you whether you should think about these guys being off on their own dimension, or you should think about them as being another thing, like literally like a different topic structure talking about different stuff. This turns out more concretely when you're trying to scale AAFD, as some of us stupidly did, where yeah, you want to know, are they just disappearing off in their own way, or are they off ideology, as it were, or are they something different, as it were? Disjoint, shall we say? Disjoint so much that we can't scale them. It's nothing like the AFD to close down a conversation, I find.
Well, let's see if there are some more questions in the audience. But yes, Hong has a question. Please go ahead. I'm afraid we can't hear you.
Oh, really?
Yeah, now we can, but very quietly.
Okay. So
this is better now. Thank you.
Now? Yeah. So I'm thankful that this SSDL is a little bit off the regular schedule so that I can join. But anyway, my question is, it seems that, okay, thanks for the talk. And it seems that part of the problem of the scaling is the sparse matrix nature of the document term matrix. I was wondering whether or not making it dense would making it better for scaling. For example, like using document embeddings and stuff like that would make it better. Yeah.
Wow. I had not thought about document embeddings. That kind of happened while I wasn't looking. So that sounds like a promising idea. Could you elaborate?
So the idea is to train word embeddings, or we know what it is, but if we have a series of words, which is back of word embeddings, and then we can also train a document embeddings. That document embeddings would be comparable across document. So, for example, if they are very similar to each other, they have a very close cosine similarity. For example, I don't know whether or not it could improve the situations.
That is something I'd like to see worked out. Yeah, that sounds fun. Anyone else have more experience with those things than I do? Aside from making rude remarks about glove being scaling, I don't really have anything sensible to say about embeddings. But thank you. That's useful.
Well, I have been experimenting with using word embedding vectors instead of the term document matrix, but the results were pretty similar. I've not tried document embeddings yet, but maybe that would be the next step. So what I tried to group together features that have very similar word embeddings, basically to reduce the features and reduce the heterogeneity inside the matrix and reduce the number of reduce its sparseness, basically. But the results were very, very similar to the previous approaches with just using a cropped DFM, which is basically what I'm doing a lot. I'm just trimming the DFM based on the document overlap. So I use only features that occur in a large share of documents,
right?
Which makes the estimation a lot clearer, but also, of course, reduces the size of the vocabulary, which again, then you get less
right.
features.
So it reduces the size of the vocabulary, and in the same way that like propensity score matching changes the subject, it also changes the subject, right? In some sense, like you've decided that there's a document that everything that doesn't occur often enough is as it were out of scope because there isn't support.
Yeah, again, this is very specific, I guess, to my applications with Twitter data, because Twitter is like 50% noise, even among politicians. They talk about stuff that's very, I don't know, very local or relates to stuff that is not talked about by other politicians. So that is the argument behind it. We want to have a scale on ideological stuff, and ideological stuff should be something that is at least shared among 15% of politicians, if it really matters in the terms of a political dimension. That's the rationale behind that.
Right, although that seems to mix the basic space with the larger space thing, right? So I mean, the idea of the basic space is that it's a conglomeration of the larger dimensional thing, because a lot of the individual stuff is effectively equivalent with respect to its effect on positions in the basic space. And so, but rather than like bundling them together, which I thought was your original thought, I'll take everything that's like 3.2, regardless of what it's about. And then I'll say, like, well, you guys, you're now the same word, and we'll just do that.
Yeah,
that would be closer to the basic space picture. But choosing among them with enough overlap, that would seem to not aggregate. And it would all be the same. It would just like strip out all the core.
Okay. Yeah, this is why I was experimenting with the word embedding stuff, because you lose a lot of variation, of course, and a lot of meaningful variation, maybe if you just crop it. And I totally get that problem. It's just, this is why I try to develop this into the word embedding approach, but up until this point, it did not work. But I think the problem is really how to put these word embeddings as vectors into the model. I'm not sure whether I did this correctly or not.
Yeah.
Okay, any more questions from the audience? Well, in this case, Will, do you have any more questions for the audience?
Well, I've already ignominiously just asked people things, so I'll try not to be quite so rude to everybody else. I would ask my esteemed co-author, but she's secretly snuck off and made the tea, so I think. Nicole, you still out there? No. And I can also make rude remarks about Thomas Geschwind because he's not here.
All right.
I would never do that, Thomas. Never.
We're still on record, so good thing you
We
said
have to,
that.
absolutely. That's exactly why.
Okay, so if there's no more questions from the audience, Will, thank you once again so much for the presentation, for the stimulating discussion here today. And Will is still in Mannheim. Feel free to send him an email if you want to meet with him. And we'll see you at our next event in late November when Fabian Lind is going to present in the MZES Social Science Data Lab. Okay, until then, see you. Bye-bye.
Well, thank you all.